everybody, BC here, and I'd like to talk about, kind of revisit the comparison of blood and brain mercury levels in infant monkeys exposed to methylmercury and thimerosal by Burbacher et al. What you have here is our monkey on the left, and on the right in black we have different forms of mercury. The total mercury in kind of a square there, rounded square, inorganic mercury in the triangle, and the organic mercury in the circle. And so what was done in this paper is they were dosed these animals, these monkeys, with organic mercury, either in the form of methylmercury via oral, or thimerosal via a intravenous shot. And you can see here is what the idea was you get the organic mercury inside the body, and then see how it breaks down. Does it break down into inorganic mercury and organic mercury? Does it stay as organic mercury in the particular form in which the monkey was dosed? How exactly is it distributed in different organs throughout the body, blood versus brain, and whatnot? Big questions, especially for the people who believe in the thimerosal hypothesis, or the idea that autism is nothing but mercury poisoning. But in fact, what would happen if, in fact, you were dosing this animal with not just organic mercury like you thought, but in fact a mixture of inorganic and organic mercury? Well, then, how can you assess exactly what's going on inside the body when you harvest organs or harvest the blood and test? And this is what Burbacher did in Figure 2 here, I believe, where they very nicely modeled the total blood mercury. The total mercury in the blood of an animal following doses of methylmercury, and you can see here at time 0 on the left, all the way to 49 days, as the animal gets dosed with the methylmercury, the blood mercury, total blood mercury, goes up, and then it starts coming down, and they dose it again, it goes up and whatnot. And so just as expected there. We have total amount of mercury. Okay, they're not differentiated in between different flavors, whether it be organic or inorganic. It's just total amount of mercury. And we have I'm showing blue being the brain here, and red being the blood, where how much mercury is being tested or is being found in either the blood or the brain. And that's really what we're going to look at with the next figure. Once again, we're looking at total mercury, and that can be a combination of inorganic and organic forms. Whereas one might want to say, hey, it's going to be organic because they gave them organic, or whatnot. We just don't know, and that's what's really bothering me. That's kind of a theme I'm emphasizing here. So you see here, Figure 3, we have concentration on the y-axis, and the x-axis is days after the last dose. So they went through this schedule of dosing the animal with methylmercury via the oral tract, and you can see here on this semi-log plot, blood in blue and brain in black, and it's the amount of mercury, the concentration of mercury found in these particular samples. What really bothers me about this particular figure is, in fact, that it is semi-log. It does not need to be in any way, shape, or form. And in fact, if it was semi-log, you would see that the slope of the brain data is going to be actually sharper than is the slope for the blood data. The semi-log nature of this plot skews the data in such a way that it makes it appear that the mercury is being excreted from the blood much faster than the brain, and it is just not. If you actually look at the data, what happens then if you actually break down and say you break down this analysis and take a look, how much is inorganic, how much is organic? Again, assuming that you can go ahead and assume that you dose the animal with just pure organic mercury, but we can't because it was never tested. So we're going to just say that hey, we have total mercury in black in the animal, and we're going to test inorganic versus organic. Inorganic on this particular graph, Figure 4, being in blue, and organic being in black. And of course, this was performed with an organic extraction, and then going through the same assessment of how much mercury is in there. And as you can see, the slopes of these lines are almost identical, but there's huge scatter on these plots. I mean, that's massive scatter. This is a semi-log plot, and there's scatter. I mean, this is ugly data, but that's the way a lot of biology is. Okay, there's just going to be scatter, and they do the best they can. They got some regressions there, and you can see that again the slopes are about the same. So the half-lives really, or the rate at which mercury is leaving this particular organ, which is the brain, is about the same. Again, based on the methyl mercury, the dosing of methyl mercury. And switching over to thimerosal, the Burbacher group, what they wanted to do then is model the blood mercury given thimerosal dosage. So you can see here, starting at 0 on the left-hand side of the x-axis, all the way up to about 49 days on the right-hand side, and the mercury goes up immediately following the injections. Again, this is testing total mercury, not differentiating between in between inorganic and organic, but you can see up, down, and corresponding with the injections of the thimerosal. And what is really interesting is that by day 42 it goes right back down to the very beginning. So it pretty much blood mercury is gone. And you can see here then on the next figure, concentration of mercury in either the blood or the brain, blood being in blue, brain being in black. And you can see then here that there's a definite increase in the rate at which the mercury is leaving the bloodstream as opposed to the brain. And that makes sense. The blood is getting cleaned out, you're excreting via either stool or urine the mercury, whatever form it is in, of course. And again, we don't know what form was injected in because it was never tested. So you can go ahead and assume all day long that it was organic mercury, that it was intact thimerosal, but we just don't know. So it's a huge assumption, and it's one that really should have been tested. Again, this is days after last dose on the x-axis, and you can see then the blood mercury decreasing significantly. Has a half-life of about 6.9 days, whereas the brain mercury has about a half-life of about 24 days. And this is total mercury, not inorganic versus organic, but that was total mercury in the blood. Now, if we again assume that we have thimerosal injected, go ahead and assume all day long that it's intact, but we don't know, and then test for inorganic versus organic forms of mercury in the brain. Again, this was not done in blood, and that really bothers me. I don't understand why, but the bottom line is it wasn't done. So let's take a look at the data. And here again we have in blue inorganic forms, and in the black we have organic form of mercury following the days after last dose of the thimerosal shot series. And the data are really clustered together on the left-hand side of this graph, whereas on the right-hand side you have some separation, although there's massive scatter. And what they're saying then is that the inorganic just doesn't ever leave the brain, whereas the organic leaves at a significant rate. Again, we just don't know. We have to assume that there is organic and inorganic forms of mercury in the thimerosal preparation. I mean, you just have to make that assumption. It just wasn't tested at time 0. It wasn't tested during the shot series itself. They only tested the inorganic versus organic portions following the last dose of whether it be methyl mercury via oral or the thimerosal via IV injection. And over here on the right-hand side, I have blood. There was never tested the inorganic versus organic phases of mercury for the blood. I just don't understand why. It seems like there was data that was just, well, I'll say it, hidden. And that really bothers me. Because if you don't know what goes in, and you're not really measuring what goes out, then how can you take a look at this data that has a tremendous amount of scatter and pull anything meaningful out of it in any way, shape, or form? We don't know what goes in. We don't even know what's going out. We know about half of the picture of what comes out, and that's it. And that's really too bad, because this could have been something really interesting and really special. But as it stands, I'd have to say this entire paper is inconclusive. Everybody's got something to hide.